Dhaka, Higher Maths 2017, question number 1. In question 1, the functions f and g go from the reals to the reals and are defined by the function of x is equal to 2x plus 2 over x minus 1 and g of x equals x minus 3 over 2x plus 1. In part A, we have to find the domain of f. Well, to solve this, in part A, x can take any value other than 1. Now the reason for that is that if x equals 1, then the function of 1 is equal to 2 times 1 plus 2 over 1 minus 1. So the function of 1 is equal to 4 over 0, which is undefined. It's not possible to have a fraction with a 0 on the bottom. So the answer is the domain of f is the real numbers r minus the set containing the number 1. R minus the set 1. Now in part B, we want to show that g is 1-to-1 and an onto function. So we want to show, first of all, g is 1-to-1. Now we've got g of x is equal to x minus 3 over 2x plus 1. Again, the denominator, 2x plus 1, cannot be 0. Now that means 2x plus 1 cannot be 0, and so x cannot equal minus a half. So the domain of g is equal to r, the real numbers, minus the set containing minus a half. Now, a function is 1-to-1 if every member of the range, the image set, is mapped onto by only one member of the domain, the object set. So, if a and b are elements of the domain of g of x, then the function is 1-to-1 if g of a being equal to g of b implies a equals b. So for our proof, let a and b be elements of the domain. We need to prove that if g of a equals g of b, then a equals b. Now, g of a equals a minus 3 over 2a plus 1, and g of b equals b minus 3 over 2b plus 1. If g of a equals g of b, then a minus 3 over 2a plus 1 equals b minus 3 over 2b plus 1. If we cross multiply, we get a minus 3 into 2b plus 1 equals b minus 3 into 2a plus 1, and we can expand the brackets to give 2ab plus a minus 6b minus 3 equals 2ab plus b minus 6a minus 3. Now we can cancel the 2ab on each side, and we can cancel the minus 3 on each side. So if we add 6a and 6b to both sides, we end up with 7a equals 7b, so a equals b. So we have shown the function is 1-to-1. Now, to show g is onto, we want to show that if y is an element of the range of g, then there exists an element x such that g of x equals y. So, let y equal g of x. Then y is equal to x minus 3 over 2x plus 1. If we multiply both sides by 2x plus 1, we get y into 2x plus 1 equals x minus 3, and if we expand the brackets, 2xy plus y equals x minus 3. Now we want to get all the x terms on one side and all the other terms on the other side. So that gives us 2xy minus x equals minus y minus 3. Well, we can change the sign all the way through and get x minus 2xy equals y plus 3. So if we factorize the left-hand side by taking x out of the brackets, we get x into 1 minus 2y equals y plus 3. Now we can divide by 1 minus 2y, and so we get x equals y plus 3 over 1 minus 2y. Now, x exists for all values of y except y equals a half, because again we'll get the denominator equal to 0. So there is no element of r, the real numbers, that is mapped onto a half. So g is not onto unless its range is the real numbers minus the number a half, r minus the set containing a half. Now in part C, we're given if 3 times the inverse function of x is equal to x, then find the value of x. Now to solve this, we have if 3 times the inverse function of x is equal to x, we can divide both sides by 3. So then, the inverse function of x is equal to x over 3. Now if we take the function of both sides, that gives us x equals the function of x over 3. So x is equal to 2 times x over 3 plus 2 all over x over 3 minus 1. Now, if we multiply the top and the bottom by 3, we'll get x equals 2x plus 6 over x minus 3. And if we multiply both sides by x minus 3, we'll get x into x minus 3 equals 2x plus 6. So if we expand the brackets, that gives us x squared minus 3x equals 2x plus 6. If we take all the terms over onto the left-hand side, we'll have x squared minus 5x minus 6 equals 0, which we can factorise. We want two numbers that add to make minus 5 and multiply to make minus 6. They are minus 6 and plus 1. So when we factorised it, we get x minus 6 into x plus 1 equals 0. Now if two numbers multiply to make 0, one of them must be 0, so x minus 6 is 0, or x plus 1 is 0, which means x is equal to 6, or x is equal to minus 1. And both these answers are in fact valid.